Once upon a time, there was a farmer named you, and you went to a fair and you bought some cabbages, and a goat, and a wolf. You were at the fair, you were in a good mood, you bought a wolf. But it complicates your return journey because your boat can only carry one thing at a time. And wolves eat goats, so that was no good. And goats eat cabbages, so that's no good. So maybe you've heard this puzzle before. How do you get all three things safely to the other side? So today we're going to tackle this puzzle using two different programming languages. My name is Jason. And I don't think of myself as a programming language hipster, but I have to admit, I kind of collect them. I'm cursed with good taste in programming languages. And I flew across the country to hook y'all up with two amazing indie languages that you've probably never heard of. These two languages, I picked them because they're full of surprises. You won't learn two whole languages in the next 9 minutes, but you will go, what? Like half a dozen times. In Form 7, some of you know this one. In Form 7 is a language for describing small, finite virtual worlds with rooms and objects in those rooms, and then running interactive simulations in them. Also, for some reason, Inform 7 code looks kind of like English, so you can start an Inform project like this. Chapter 1, the East River Bank is a room. You can also add some documentation. So we're saying, OK, new room. It's called the East River Bank, and Inform knows that a room is a particular type of object. It's a place where you can put stuff. Chapter 2. The boat is an enterable container. Inform knows what enterable and container mean. So here we're defining another object called the boat and telling Inform what type it is and where it is. There's a sort of class hierarchy in Inform, so we can define types by saying things like a treasure is a kind of thing. And then if we define a wolf and so on, and then we say the wolf, the goat, and the cabbages are treasures, that means that, well, it means exactly what it looks like. They're treasures. Why am I explaining English to you? Now, if you've kicked around for a while, you know that there are other programming languages that have this same gimmick. You know, they look sort of like English. Here are a couple of them, but I could fill a lot of slides with these. What these all have in common is they're not fooling anyone. Like, you can tell it's code. Every word is a different stinking color. Well, Inform 7 isn't fooling anyone either, but it does take English grammar a little more seriously. It maps interesting bits of English to interesting programming concepts. So learning Inform means seeing both programming and English in a new light. For example, Inform knows that the word is has a few meanings, so you can use it to define words, to express physical relationships, or to say what type something is. Inform knows that adjectives indicate characteristics of things, and you can use is to attach an adjective to a noun, like the boat. For the purpose of describing virtual worlds with places and things, all of this is very natural. It works great, and it reads great. OK, more on this later. I have to spring something on you. When you actually run an Inform project, you get this. The prompt awaits your commands because Inform 7 is a programming language for writing interactive fiction, text adventure games. So you can say things like drops. Oh, excuse me. So you type simple commands, the game responds. And Inform lets you customize how commands are handled. You can write something like, instead of taking the boat, say, there's no point carrying a boat around. This is called a rule. Inform has this unusual execution model. It starts out a little like React, if you've used that. When the user types pick up the boat, Inform creates an object called an action that represents the user intent. And then it runs the action through a bunch of rules to decide how to respond. First, it checks your rules. So if the current action is taking the boat, it sees this, and it stops and prints this message instead. But Inform also has some built-in rules, the standard rules, which are kind of like a standard library for common sense. It contains such wonders as the can't take scenery rule, the can't take what's already taken rule, and the can't take yourself rule. I knew this would happen. I'm disappointed in everyone who laughed at that joke. A more complex rule can use syntax kind of like Python with if statements and colons and indentation to indicate structure. So there is also like a normal programming language in here. Surprise. Inform also reminds me a little bit of CSS. This first line is kind of like a selector, and they can be simple like this or complicated. There are standard rules which do something, and you can override them if they're not doing what you want. When multiple rules match, there's a system to decide precedence and so on. And most of all, actually, when you want a rule to apply, but it's not applying for some reason, it feels exactly like CSS. Still, overall, Inform is brilliant. The amount of work and love and innovation that went into it is mind-boggling. Check it out. You'll love it. Oh, two last surprises about Inform. The documentation actually is the best time you will ever have reading a software manual, I promise. It's witty, it's charming, it's full of wonderful examples. It's unreasonably good. And if you take one thing away from this talk, remember that Inform has syntax for enabling the Oxford comma, which is the nerdiest feature of any programming language ever. OK, the other language I'd like to show you is called Alloy. Now, Alloy is a little different. It looks like code. It has classes. You can say class person has a field, loves, which is a set of people. Except Alloy is a little too cool for classes, so they're called signatures. I don't make the rules. Another funny thing is there's no new operator in Alloy. You can't directly create person objects, because Alloy creates all the objects for you. You describe the world you want to see, one where there are people and there is love, and then you click the button, and Alloy creates that world for you, or many worlds. So we're going to run this model for 3 to see worlds containing up to 3 people. Alloy draws these graphs for you. And there's a next button, so if you click it, it shows you another picture. And another. And something I learned while making these slides is that love is rough. We could, of course, show this kind of data using a table with 2 columns, right? Like instead of a picture with arrows, we could use a table, same data, different form, right? And this is a very big deal in Alloy. Tables are the same thing as object fields, which are the same thing as graphs. The common idea here is called a relation, and Alloy is all about some relations. Surprisingly, Inform is too. Both languages go like real deep on relations. In Alloy, you write sig person loves set person. In Inform, you say love relates various people to various people. And it really means exactly the same thing. And then you define a verb. The verb to love means the love relation. And this lets you use the word love when writing out the source code of your game, which is like a really satisfying thing. In school, you may have learned that verbs are actions, hit, kick, run, jump, swim. But Inform knows that many English verbs express relations, verbs like love. And Inform supports both kinds of verb. And as a result, you can write some pretty amazing ideas very simply. I don't have time to explain all this, but the point is English has some powerful relational calculus kind of built into it. And it's pretty awesome that Inform has that too. And in fact, the standard rules of Inform begin with this long list of relations that underpin the simulation. This sentence defining the verb to carry is the reason that I can write the player is carrying a sack of cabbages, and Inform understands. Anyway, we're not here to make friends. We're here to tell a story about 4 specific things. Call them objects. And instead of loving each other, they want to eat each other. And here they are. Now, if I ran this right now, it would create maybe 3 wolves, which I don't want. So we have to tell Alloy there's just one of each. And now, if I push the button, what's going to happen? Well, now Alloy is going to create food webs. It's just a battle royale of cannibalism here. They say goats will eat anything, but I've never seen a goat try to eat itself. OK, Alloy is a little bit creative, and if you want it to tone it down a little bit, you have to tell it what you want to see using something called a fact. This fact says, OK, Alloy, I'm going to tell you exactly what this eats relation contains. Wolf eats goat, goat eats cabbages, that's all. And now we get just the one picture. OK, so now the interesting part. This puzzle is about getting across the river, which is something that unfolds in space and time. The space part is pretty easy. We say there's such a thing as a riverbank. But what about time? In most languages, things happen in a certain order defined by the language, or things at least happen. In Alloy, the existence of time is a library feature that you have to import. And the way it works is super weird. We're going to have to declare something that I'm going to call a snapshot. See, once we have time in our model, Alloy isn't just going to generate pictures, it's going to make a kind of movie for us. A snapshot is one frame of this movie. And what's in a snapshot? Well, the only thing we need to track is the location of everything. So each snapshot has a field that maps each object to the one riverbank where it is. That arrow means relation, and we'll also see it shows up quite literally as an arrow pointing from each object to one riverbank in the graph. And then we open the ordering module, which just says that there's a linear sequence of these snapshots. It gives us something called first, which is the first snapshot, something called last, and so on. OK, what does Alloy show us now? All right, so at the bottom you can see there's a control for clicking through the sequence of snapshots. And Alloy is showing the location relation as advertised. But we notice something funny. There's only one riverbank, which is unusual for rivers. They usually have two. Maybe it's a Mobius river. I don't know. So we can fix that with another fact. Say the number of riverbanks is 2. And there we go. It's better. Except that the goat is starting out on the other side of the river. What is it doing over there? We need to add a fact that says, OK, there's one bank that's the first location of all objects. And there's one bank that's the last location of all objects. And they're different banks. And then, sure enough, all 4 objects start out on one riverbank. And if we click through, then they end up on the other riverbank. So you can see how we have to tell Alloy every little thing. I said earlier how Inform has a bunch of common sense rules in its standard library. Yeah, Alloy doesn't have any of that. What else are we missing? What other rules are we missing? Well, maybe you can figure that out for yourself. But just for example, we haven't written any rules about movement yet. So these objects are all free to teleport back and forth across the river at their leisure. There are a few other bits missing too. All in all, the solution's about 40 lines of code, and it does work. I'll link to it later. So what is Alloy for? It's not for solving old logic puzzles. That's not what this language is for. The idea is that when you're designing a complex system, you pick some aspect of it that's interesting. You make an Alloy model of just that part, and then you can tell Alloy, this is broken if all threads get blocked, or this is broken if 2 different servers can give different answers, or whatever. And then you say run broken for 10, and if it's broken, Alloy shows you a picture of the exact test case that breaks your design. Pretty cool. You do have to have a system that's complicated enough that you want help, but simple enough that you want to model it in Alloy, which is a lot of work. So is this useful in the real world? I don't know. Maybe? Why am I even talking about this? I love weird programming languages. I love having to think in weird ways. But what I love best is when a weird language is trying to do something. It has a mission that explains why it's like that. I aspire to be that kind of person myself. So far, I'm just weird. I love that Inform is a huge language with a 27-chapter manual and a rich set of standard rules, because English is a really good language for talking about rooms and people and everyday things. I love how Alloy reduces fields and data structures and time to a single unifying idea of the relation, because then it can use powerful logical analysis tools to find bugs in software before it's built. These languages surprised me. Languages like this remind me that there are whole other kinds of programming. There's more out there. There's more delight left in programming. There are more surprises waiting to be discovered. Some days I need that reminder. Thank you.